difference quotient practice. So we're going to take this function right here, and f of x equals 4x squared, and we're going to add this h in here, and it's what we're doing with a, b, and c is we're making the building blocks to what c finally gives us here. This is the difference quotient formula right here, and so it's just kind of setting you up. And so right here, the first thing you do is rewrite the function with, instead of just the one variable x, you're going to write x plus h, just like how it writes right there instead of the x. So rewriting it, f of x plus h equals 4, and we'll write times x plus h, and we'll keep the squared on the outside. And for b, so we know that, so we're going to just rewrite it, 4 times x plus h squared, and we already know the original, it's f of x equals 4x squared, so we'll write minus 4x squared. And now we have the entire top line that we need for the difference quotient. And so for c, and c is where we really begin the process. So I'm going to drop it down here, and I'm going to put all of this that we made here in b, I'm going to put all of it over h. So f of x plus h minus f of x over h equals, well, we already wrote it for b, 4 times x plus h squared minus 4x over h. So from here we can expand out this x plus h squared, and to just crunch out what that would be, x plus h squared, or will be, you just rewrite it, and since it's squared, there's two of them, so just rewrite both of them next to each other, x plus h times x plus h, and from here just use the FOIL method, so you'll go firsts, and then outsides, and you're multiplying these, and insides, and lasts. So, and that's going to give you x times x, x squared, and outsides, x times h plus xh. Insides is hx, but we can just rewrite that as xh, and then lasts, h times h is h squared. You just rewrite this as x squared plus 2xh, since there's two of them, plus h squared. So don't forget also there's a 4 outside of here so each of these terms in this case are going to be multiplied by 4, and so we just go ahead and do that now just to knock it out. We're going to have 4x squared plus 8xh plus 4h squared, and so we'll just rewrite this down here over h, so we'll have 4x squared plus 8xh plus 4h squared, just from right here. And remember, this is just from the first portion, so we still have to tack on that minus 4x squared. Sorry, it should have been squared right there, because we pulled it from right here, 4x squared. And so we have the original on the end, and then the plus h version on the left of the subtraction right here. We're going to put all of it over h, and you'll notice that you can cancel out these two terms right off the bat, this minus 4x squared and this positive 4x squared, and that will give you 8xh plus 4h squared over h, and you'll see there's this h in this denominator. We can just get rid of that right now. Each term has an h, in the numerator, and the only term in the denominator is an h. So what we can do is just cancel out one of the actual arithmetic to do it would look something like this. You pull the h out, so you'll have h times 8x, pulling it out of that, plus 4h. And notice that it doesn't take, and we'll just close it, and that's over h. And you'll notice that the 4 is still going to have an h attached to it because this was 4h squared, so there was 2 h's. And pulling it out of the numerator, the h out of the numerator, that only took one of those h's. So these 2 h's in the numerator and denominator will cancel out, and now we're left with 8x plus 4h. And what we can do with this right here is, that was the difference quotient, and for now if we want to say, well, what's the derivative of the function, you want to find this as the limit as h approaches 0, because h is the change in x. It's delta x. This represents both of these, h and delta x. They both represent the change in x. And so if we want to find the limit as h approaches, as the change in x approaches 0, the derivative, that we apply the limit to 8x plus 4h, and you'll see that limit of, as h approaches 0, 8x is going to just remain 8x, and the limit h approaches 0 of 4h is 0, leaving us with just 8x. So we have 8x. If we wanted to find a derivative, notice that it didn't ask us for that. It just asked for the difference quotient. Practice. And but just know that once we reached right here and we simplified down to 8x plus 4h, that's as simplified as it could get. From there, we apply the limit as h approaches 0, and that gives us the derivative. So the derivative of 4x squared is 8x, and we could check that really quick with Leibniz notation. So if we had f of x equals 4x squared, and we did ddx 4x squared, you would drop the 2 down, multiply it to the 4, and then you would subtract the 2, subtract 1 from the 2, and that would give you, so 2 times 4 is 8. The x remains there, and 2, the exponent gets subtracted by 1, so it'd just be 8x. And so both ways, you have Leibniz notation over here, and the limit as h approaches 0 of the difference quotient on this side.